Let's continue the discussion about section 1.1. We're going to solve linear equations. Okay, so first, what is a linear equation? So a linear equation in one variable is equivalent to an equation of the form ax plus b equal to 0. Okay, where a and b are real numbers and a is not equal to 0. Okay, so when a is 0, you only have b. b is equal to 0, so it's not interesting. It's like, it looks like 0 equal to 0. When a is 0, a times x becomes 0, then you will directly have b equal to 0. So a and b are both 0. That's not interesting, right? So we assume a is not equal to 0. And any linear equation, any equation equivalent to this form is called a linear equation. It's not just this form called linear equation. The equivalent equations are always called linear equation. Okay, and because here this x has degree 1, so sometimes here this is complete the definition. So sometimes a linear equation is called a first degree equation. First degree equation. It's because x has only degree 1. It is a polynomial of a degree 1. So it's called a first degree equation also. Linear first degree. Linear, this word comes from geometry. Later we will see that every straight line in the xy plane can be represented by a linear equation. A linear function can be represented by ax plus b. So line is linear. So that's why this type of equation is called linear. This is from geometry. This is from algebra. It has degree 1, degree 2, that is algebra. Okay? So when we have such standard form, you can call it a standard form. When we have such standard form, how do we solve it? We first subtract b from two sides. We subtract b from two sides. Left side minus b, the b cancelled. So right side 0 minus b is negative b. Right? We subtract b from two sides. And second, we're going to divide this equation by a. Remember, when we do the division or multiplication, make sure that number is not 0. And here, we know that once we're talking about the linear equation, this a is not equal to 0. So we're going to divide two sides by a. We divide two sides by a, we will cancel this a, and the answer will be negative b over a. So this is the answer. It has just one solution. So the solution set is negative b over a. It has single solution. All right? Okay, so this is the general discussion. Let's see the concrete example. So solve the equation. One half x plus 5 minus 4 is equal to 1 over 3, 2x minus 1. Alright? Okay, so on two sides of the equation, you have fractions. Fraction number, they are not as simple as the integers. So when you have fractions, we're going to multiply this equation by 6. 6 is the least common multiple of 2 and 3. We multiply two sides by 6 in order to simplify the fraction to the integers. Okay, so multiply two sides by 6. When we say that, we mean every term from each side will be multiplied by 6. So this first term times 6. Let's do it here. And the 4 should be also multiplied by 6. This is one term. The product is one term. 4 is the other term. And here is a 6 times 1 over 3 times 2x minus 1. Right? So you don't forget the multiplication with 4. Okay, and then we simplified. 6 times 1 half is 3, so it's a 3x plus 5 minus 24 is 6 times 1 over 3 is 2. 2 times x, 2x minus 1. And then you continue the simplification. You will get 3x plus 15 minus 24 is equal to 4x minus 2. Distribute 3 into the parentheses and distribute 2 into the parentheses also. Right? And then let's continue the simplification. So it's 15 minus 24 is minus 9, negative 4x minus 2. And we're going to move 4x to the left side. It becomes a minus. Move negative 9 to the right side, it becomes plus. Right? When you do this movement, or you're going to say, we add 9 for two sides. We add 9, we will cancel this negative 9. The right side will have 9. You subtract 4x from two sides. This 4x disappeared. The left side will have minus 4x. Either you say move. When you say move, you need to change the sign, or you do the subtraction or the addition, subtraction or addition, respectively. All right. So 3x minus 4x is negative x. 9 minus 2 is 7. Negative x is 7. X is negative 7. Right? So this is the single solution. It is the single solution. All right? Okay, very good. Second example. Solve the equation. (2.78x plus 2 over 17.931 equal to 54.06. Okay, this example will tell you how you write the final answer in the exam without a calculator. Be careful, this, if you have similar problem in the exam, you are not allowed to use calculator, never in the exam. Okay, so let's see what you're supposed to write. So first, this is a number. You can never simplify it. Even you do the long division, you do the division, it will be infinite decimal numbers. Don't do that. So you just consider this as a number. You're going to move this to the right side. You move this term to the right side, plus becomes minus. So the subtraction is, the subtraction gives us a number. You don't simplify it. Remember, don't simplify. Just leave this subtraction like this because they are so complex. They are not like the integers. If you have integers, you're going to simplify. Like 9 minus 2, you will not write like 9 minus 2. You will write 7. But this number, leave it like this. So ax is equal to this number. You're going to divide the equation by 2.78. So you divide two sides by 2.78. And this is going to be your final answer. Don't simplify it. Don't use calculator. Okay, this form is the final answer. It's acceptable. Any approximation, any truncated or rounded decimal numbers are not accepted. Okay, this one is answer, standard answer. But if you have integers, you're supposed to simplify it, either get a fraction or get another integer. All right? Okay. So whenever you have a linear equation, you can always do this and do these similar steps. And the final step, almost the final step, you always write all the x terms in the left-hand side and all the numbers in the right-hand side and do the division as a final step to get the answer. Linear equation will just have a single solution. If you get a multiple solution, it's wrong. Okay? And second, let's solve the equation. Solve equations that lead to linear equations. So the equation itself is not a linear equation, but after several simplification, it becomes a linear equation. Okay? Okay, let's see. Solve the equation two y plus 1 times y minus 1 is equal to y plus 5 and 2y minus 5. Okay, let's try to solve it. Before we solve it, we need to simplify it. We do multiplication term by term. So for example, let's see, for the left side, you use 2y times y, you get the 2y squared. 2y times negative 1 minus 2y. And then, okay, so 2y is used for both terms, and then you move to 1. 1 times y is y. 1 times negative 1 is minus 1. Okay, so this is left side. The product will give you 4 terms before the simplification. And for the right side, y times 2y, 2y squared. Y times negative 5 is minus 5y. 5 times 2y is plus 10y. 5 times negative 5 minus 25. Okay, so this equation is not a linear equation at the beginning. It has square term. The linear equation does not have square term. Okay, but you see here, the left-hand side has 2y squared, right-hand side has 2y squared. We can subtract 2y squared from two sides. We subtract 2y squared from two sides, both disappear. Okay, so both disappear. So negative 2y plus y is negative y minus 1. Now the left-hand side, only those 3 terms give you negative y minus 1. Here, negative 5y plus 10y is a 5y minus 25. Okay, so now this becomes a linear equation. It does not include the square term. Square term cancelled, subtracted. Okay, so you move this 5y to the left side. That becomes minus 5y. Negative 1 to the right side becomes plus 1. Positive, move to the other side, negative. Negative, move to the other side, positive. Okay, negative 1 minus 5y, negative 6y. 1 minus 25 is minus 24, negative 24. And then y is negative 24 over negative 6. Negative, negative cancel. 24 over 6 is 4. So the answer is 4. It has only one solution. Okay? So this equation has just one solution. The original equation is not a linear equation, but in the during the simplification steps, the square term from two sides are cancelled, so only linear term, first order term survives, then it becomes a linear equation. So that's what they say, equation that lead to linear equation. Right? Okay, let's see next. Let's see next. Next example. Solve the equation 3 over x minus 2 equal to 1 over x minus 1 plus 7 over x minus 1 x minus 2. This equation is not a linear equation because it has a fractional expression and the x appears in the denominator. It's like the rational numbers. We multiply the least common multiple in order to transform rational numbers into integers. Here's a similar thing. You see here the denominator contains x minus 1, x minus 2, x minus 1, x minus 2. So the minimum, the least common multiple of the denominator. Let me copy it here first. The least common multiple of the denominator is x minus 1 times x minus 2. So we are going to multiply two sides by x minus 1 times x minus 2. Okay, we multiply two sides by the least common multiples or least common denominator. Okay, then here x minus 2, x minus 2, they're cancelled. So you have 3 times x minus 1. In this, you have to distribute this product into the bracket. So it's a 1 over x minus 1 times x minus 1, x minus 2, plus 7 over x minus 1, x minus 2 times x minus 1, x minus 2. Okay, let's continue this. If you are familiar with this process, of course, you don't have to write those steps. But if you are not very familiar with this computation, it's better for you to write extra step to clear your mind. Okay, so here you are going to cancel x minus 1 from the factor and the denominator. So you get 1 times x minus 2. In this, x minus 1 cancelled. You can only cancel product, the factors from product. You cannot cancel the term from the addition and the subtraction. And here x minus 2 cancel. This is a factor of a product. So the whole denominator and this factor are completely cancelled. Then denominator is 1. 7 over 1 is 7. Okay, so you cancel all the terms from the denominator. Denominator becomes 1. 7 over 1 is 7. Okay, let's simplify it. 3 times x minus 1 is 3x minus 3. X minus 2 plus 7 is x plus 5. You see, at this moment, it becomes a linear equation. So how do you do that? You're going to move x to the left side, negative 3 to the right side. X, it has nothing, no sign, it is positive. If there's no sign, means it's positive. When moved to the left side, it becomes subtraction. Negative 3 moved to the right side becomes a positive 3. Okay, 3x minus x, 2x. 5 plus 3, 8. 2x is 8, x is 4. So this is the solo answer. When you get this answer, you need to go back and check it. The reason you have to check is that you do the multiplication. And this multiplication, you have to make sure this is not 0. In other words, you just check your answer is a solution of a original equation or not. So when x is 4, the left-hand side is 3 over 4 minus 2 is 3 over 2. And the right-hand side is 1 over 3. 3 is 4 minus 1, 1 over 3. 7 over, you see, 4 minus 1, 3, 4 minus 2 is 2. So it's a 6. 3 times 2 is 6. We'll plug in x equal to 4. And the least common multiple on the 3 and the 6 is 6. So the first one is 2 over 6. You multiply top and bottom by 2 in order to get 6. And 2 plus 7 is 9 over 6. And you cancel the common factor 3, it's a 3 over 2. You see, the left-hand side is a 3 over 2, right-hand side is 3 over 2. So x equal to 4 is the solution. X equal to 4 is the solution. So in most cases, if you do not multiply the equation by an expression, if you just multiply the equation by a number, you don't have to always check the answers. But once you multiply the equation by an expression or divide the equation by the expression, you have to check your result. Okay? Don't divide the equation by an expression. Sometimes you may lose solutions. Okay? Okay. Let's continue. Solve the equation. Three x over x minus 1 plus 2 is equal to 3 over x minus 1. Okay, so this problem is similar to the previous problem. The denominator involves variable x. Fortunately, they share the same denominator, x minus 1. So let me copy it here first. So our first step is to multiply this equation by a proper term so that we cancel the denominator. Because both denominators are x minus 1, so we're going to multiply the left and the right hand side by x minus 1 so that we can cancel this x minus 1 from the denominator. Okay, so here the left hand side you have to distribute this x minus 1 into the parenthesis or bracket. So it's x minus 1 times 3x over x minus 1 plus x minus 1 times 2. Don't forget this multiplication with 2. Here x minus 1 cancel. This time you consider x minus 1 as one term, so you can completely cancel it. After you cancel this, the denominator becomes 1. 3 over 1 is a 3. And here is a similar thing. You cancel x minus 1 from the factor and the denominator. So it becomes a 3x And this 2 times x minus 1 is 2x minus 2. Alright? And then 3x plus 2x is 5x. Negative 2 move to the right side becomes plus 2. 3 plus 2 is 5. 5x is 5, x is 1. X is 1. Remember, you have to check it. You plug in x equal to 1 into the original equation, 3x over x minus 1. This is left hand side. But for x equal to 1, when x is equal to 1, the denominator becomes 0. So left hand side is undefined. The left hand side is undefined. So your solution does not satisfy the original equation. Your solution satisfies this linear equation, but not the original equation. So the original equation so x equal to 1 is a unique candidate. It does not satisfy the equation, so the original equation has no solution. Okay, the original equation has no solution. Whenever you have denominator, you do some multiplication to cancel the denominator. Make sure you go back to check your solution. This solution could be the solution of a the later linear equation, but this solution is not this number is not the solution of a original equation. Okay, be very, very careful. This example, the original equation has no solution. Okay, this is a very important example. You must verify it when you have denominator. Okay, next example. Let's see some word problem. So in the US, they use or they measure temperature in both degrees Fahrenheit F or and degrees Celsius C. So two systems are used, which those two systems which are related by the formula Celsius is equal to 5/9 times Fahrenheit minus 32. Okay, so this is a relation between two systems. What are the Fahrenheit temperature corresponding to Celsius temperature of 0 degree, 10 degree, 20 degree, and 30 degree. Celsius. So, okay, so this is a complete problem. In the problem, first, some relation between those two systems of degrees is provided. This equation, we can see that whenever you know the Fahrenheit degrees by the formula, you can compute the corresponding Celsius degrees. But the problem asks you the reverse way. If I know the Celsius degrees, how do I get the Fahrenheit degrees? Okay, if I know the C degree, how do I get F degree? So we're looking for the relation from C to F. So we solve the equation for F. We solve the equation for F. So let's check. Okay, so how do we do that? We first multiply or first we divide, not do, divide two sides by 5/9. Divide two sides by 5/9. This term disappears, so it's F minus 32. Okay, 1/5/9 is 9/5, so it's 9/5. C. It's F minus 32. And then you move this 32 to the other side. Right? And then you interchange two sides. So this is the general formula from the C degree to F degree. So 9/5 times C plus 32 is the F degree, Fahrenheit degree. Okay, so now we're going to plug in the Celsius degree equal to 0, 10, 20, 30. So C is 0. So the F is 9/5 times 0 plus 32, which is 32. 0 times any number is 0, plus 32, 32. When the Celsius degree is 10, so F is 9/5 times 10 plus 32. 10, 5, you cancel 5, you get a 2. 9 times 2 is 18. 18 plus 32 is 50 degrees. So the Fahrenheit degree is 50. For the Celsius degree, 10. When the Celsius degree is 20, Fahrenheit is 9/5 times 20 plus 32. So 5 cancel with this 5 from 20, you get 4. 4 times 9 is 36 plus 32 is 68. So the Fahrenheit degree is 68. When C is 30 degrees, the F is 9/5 times 30 plus 32. You cancel 5 here, you get 6. 6 times 9 is 54 plus 32 is 86. So what are the Fahrenheit temperature corresponding to Celsius temperatures of them? So you get the corresponding temperatures. 1, 2, 3, 4. You have 1, 2, 3, 4. You have them. See? So that's the answer. So basically, you solve F in terms of C. You solve F in terms of C. F becomes a function of C. Okay. Now let's see another word problem. Investment word problem. So a total of 18,000 is invested, some in stocks and some in bonds. If the amount invested in bond is half that invested in stocks, how much is invested in each category. Okay, we are looking for the amount of the money in two investments, and the total both the sum of them is 18,000. Okay, so how do we solve that? We're going to name the variable, and we're going to try to solve the variable. So see here, the amount invested in bonds is half that invested in stocks. In other words, the amount invested in stocks is twice that invested in bonds. You see twice, you multiply by 2. You see half, you multiply it by one half. That is a rational number. So for me, I prefer to use integer, not rational numbers. So let's see, assume that X dollars are invested in bonds. X dollars are invested in bonds. Then 2x dollars are invested in stocks. 2x dollars are invested in stocks, right? The bonds is a half of the stocks. So bonds is x, the other one will be double. Okay, then the total is 18,000. You mean the x plus 2x is 18,000. That is a relation. That is a condition here from the first sentence. Okay, then you will see this 3x is 18,000, then x is going to be 6,000. 18,000 over 18,000 is divided by 3, you will get 6,000. So $6,000 are invested in bond. So 2x is $12,000 invested in stocks. Okay, so your problem is not just to solve the equation. Your problem is to answer the question. So $6,000 are invested in bonds. $12,000 are invested in stocks. See, that's it. In the textbook, they use X to represent the money invested in stocks, then the money invested in the money invested in bonds will be one half x, then you will see the rational number. But this way you will just see the integer, you don't see the rational number. That's an advantage of this type of setting. Okay? Okay. Next example. So Shannon grosses Shannon grossed $435 1 week. By working 52 hours. A week, 52 hours. Her employer pays time and a half for all hours worked excess of 40 hours. Okay, so when she works more than 40 hours, the extra hour she got paid a time and a half, 1.5 salaries. Okay, with this information, can you determine Shannon's regular hourly wage? Regular hourly wage, not the wage excess of 40 hours. Okay, regular hourly wage. Okay, so let's see. So we don't know what the hourly wage is. Just let X be Shannon's hourly wage. X dollars be Shannon's hourly wage. Okay, now let's try to get this $435 a week. Okay, so first Shannon get regular paid in the first 40 hours. So each hour she got X dollars. 40 hours she got 40 X dollars. And after 40 hours, I mean, she actually worked 52 hours. So after 40 hours, she worked 12 hours. She also worked extra 12 hours. For those extra 12 hours, what is her wage? What is her wage? Her wage is a time and a half. Time and a half. This is what it means. And times X. So your X times time and a half, 1.5. This is actually 3/2. 1.5 is 3/2. So this is the hourly wage after 40 hours. so minus 40. This is a regular wage from 0th hour to 40th hour. The total is $435, right? Okay, let's continue. After we set up the equation, let's try to solve it. So this 52 minus 40 is 12. 1 plus 1 half is 3 halves x is equal to 435. Let's continue the simplification. 12 cancel with this 2, you get 6. 6 times 3 is 18 times x. So 40x plus 18x is a 58x equal to 435. So x is a 435 over 58. Let's try it and see. Let's put 7 here. 7 times 8 is a 56. 5 times 7, 35, plus 5 is a 40. 2, here's 9. Okay. What's next? Let's put 5 here. 5 times 8 is a 4. 5 times 5, 25. 25 plus 4, 29. Okay, good. So x is a 7.5. We're talking about the real problem. It is supposed to be a number, not that's not a weird number. It should be a regular number. So it's a $7.5. So Shannon's regular hourly wage is $7.50. Right? Okay, so this completely finished the section 1.1. The 1.1 is about the linear equation. If you do have a linear equation, you will get one solution. You will have a unique solution. If you have some equation which leads to the linear equation, you may or may not have solutions. Remember, we had example. It looks like having a solution, but after you check it, that number is not the solution. So when you have the denominator, when you have variable in the denominator, make sure you check the answer you get. It may or may not be the solution. Okay? So do the recommended exercise. If you have question, ask me. This section is stopped. It finished. We will start a new section in the next video. Thank you very much.